Hi everyone. I'm going to demonstrate the second experiment in Lab 9 on cellular respiration. This one is the aerobic respiration in beans, specifically kidney beans and pinto beans. The materials that you're going to need, you will need a chemical called bromthiamyl blue. And as you can see, I'm not wearing gloves, but I recommend that you do when you start using the bromthiamyl blue. You'll need 100 kidney beans, and the kidney beans come in a packet of 100. They probably include a few extra, just in case, like they break or whatever. And then you're going to need another packet of 100 pinto beans. The kidney beans, of course, they're labeled, but they're the dark red beans, and then I don't know if you can see that or not. The pinto beans are a lighter color, kind of speckled. Okay, 6 medicine cups, 6 of these. You will need permanent marker, of course. You will need tap water. You'll need paper towels for labeling. So you'll need 6 paper towels basically, because you have 6. You're going to need 6 beakers. Let's see. Labware is. This is a joke, by the way. Oh my gosh. This paraffin wax. We are supposed to be able to take this wax and wrap it around the top of a beaker. Yeah, it's never going to happen. I'm going to try and show you how to do it, but it's probably not even worth the effort. I would get some plastic wrap from your home and put the plastic wrap over the beaker and put a rubber band around it, and it will be just as effective. But anyway, they provided you with parafilm. I do not believe they provided you with even close to enough parafilm. Now, I have a whole box of parafilm, but you do not have this box. So I would just recommend that you use saran wrap. Then 6 250 milliliter beakers, you know what they look like by now. It says 1 pipette. You're going to use the pipette for pipetting your bromthiamyl blue solution, and 6 large rubber bands, and those came in the same little packet as the beans and the medicine cups, All right, so experiment 2, procedure. This time, instead of fermentation, we are representing aerobic respiration. So there will not be any alcohol produced in this one, but the procedure says step 1, label 2 of the 250 milliliter beakers as soaked pinto and soaked kidney. And you have to do that, and then you have to add 50 beans, 50 kidney and 50 pinto beans each to these beakers, and then let them soak for 24 hours. That is a must. So let them soak for 24 hours and then come back. Pause this video and just come back to this part. But then once that has happened, after 24 hours have passed, carefully strain the water from each beaker. So I'm just holding my hand over it. And then you're going to pour them onto a paper towel. These are the kidney beans, so I'm going to pour them on a paper towel that I have labeled soaked kidney. And then I'm going to do the same thing with the pinto beans. Strain them, making sure I don't lose any of the beans. This is kind of like what we did with the yeast. Soaking them it's not bringing them to life, but it's causing them to start carrying out cellular respiration. Now, the yeast carried out cellular respiration until we removed the oxygen. When we did the inverted tubes, there was no oxygen. And when there's no oxygen, instead of cellular respiration, it's fermentation that takes place. But these are going to be exposed to oxygen, so they will be carrying out cellular respiration, aerobic cellular respiration. Okay, so step 6, pour the soaked beans onto paper towels, keeping them sorted by bean type. Step 7, label the remaining beakers as dry pinto And I did the same. What I did, I took a paper towel and labeled it dry Pinto and a beaker. So I'm just putting the beaker on top of the paper towel, just as a precaution. But dry Pinto, no Pinto, dry kidney, no kidney. And then place several layers of moist paper towels at the bottom of all 6 250 milliliter beakers. Okay, so I'm not going to do this for every one, but you just take a beaker and you'll just place several layers. You'll moisten the paper towel and then you'll place several layers at the bottom of each beaker. And this gives the beans a water source during the experiment. So I'm going to press that into the bottom and pretend it's moist, but that's what you're going to do. So after doing the moist paper towel at the bottom of each beaker, then I just want to show you what it would look like set up. Okay, so now what you've got is soaked Pinto, soaked kidney, dry Pinto, dry kidney, and then no Pinto, no kidney. And this is what your setup should look like, okay? And then after that, you are going to measure 4 milliliters. And you can do that with your pipette because there is a 4 milliliter mark on your pipette. The top mark is 5, and the mark below that is 4. Actually, I don't know if you guys have noticed, but I just got glasses for the first time ever. I've been using reading glasses for a long time, and I think I've been telling you guys that this top mark was a 5 milliliter mark, so I apologize for that. This top mark is a 3, and it's very clearly a 3. I think if you fill the entire pipette all the way into the bulb, it really is 5 milliliters, but it goes up to 3. So you're going to measure 3 milliliters and then 1 more, okay? So I'm so sorry about that, but I'm so glad I got glasses. So we go up to the 3. That's not quite 3. I just got 2. So I'm going to put 2 and then another 2. And you're going to do that in all 6 of your medicine cups. I'm not going to do that for every one of them, but I'm going to show you how the setup needs to look. So I've got on the bottom, I've got moist paper towel, several layers of moist paper towel, and then I've got my beans, and in this one it would be my soaked pinto beans, and then I'm putting the Bromthymal blue, I'm not pouring it in the beaker, I'm sitting the medicine cup on top of the beans in the beaker. Then I am going to attempt to put this parafilm around the top and then a rubber band around that. But this is a very tedious, probably pointless effort because this is not enough parafilm. It's going to break. And I'm trying to go slow, and I've used parafilm for a long time because you have to if you're a biology instructor. But I have used it to cover the outside edge of Petri dishes. I've certainly never tried to stretch one small tiny piece of parafilm over a beaker. I mean, you can see this is crazy. So forget it. Get your saran wrap and put that over the top, and then take your rubber band and put around that. And that will keep, I don't have saran wrap, but just pretend. You'll have your saran wrap over the top and your rubber band around that. And then you're going to do that for all of these. You're going to add 4 milliliters of your Bromthymal blue. Sit the medicine cup into the beaker. Don't pour it in there. And then you're going to put saran wrap over the top and a rubber band around that. And then once you have done that, and by the way, I didn't say this because I wasn't reading the instructions as I explained it, but of course, in the first two, these are the soaked beans. If I would put this in order, the first two are the soaked beans, and then for the dry beans, you just count out the other 50. You count out 50 and put those in the, those are the ones that you didn't soak. They're not going to be dry because all the paper towels that you put in the bottom are moist, but you count out 50 dry, and you should have 50. And after you do that, you're going to let the beaker sit overnight. So this is a 2-day experiment, okay? So it's 24 hours to soak the original soaked beans, and then it's going to be another 24 hours that you let this sit. Note the color of the bromthymal blue. You'll be able to see it better for yourself, but it's blue. It's called bromthymal blue, and it's an indicator that changes color when the pH changes. So the bromthymal blue is blue right now, and then you're going to let it sit and record your observations in tables 2 and 3, your initial observations and then your observations after 24 hours. And of course, answer your pre-lab and your post-lab questions. I know there's some information on what bromthymal blue does. It's an indicator. And remember, indicators change color in the presence of other chemicals or due to pH change. It's kind of like a litmus paper, but it's liquid. So it's blue if it's a base, but if it turns neutral, it'll be green, and if it turns acidic, it will actually turn yellow. It's a very dramatic change from blue to yellow, and the acid in this case would come from the carbon dioxide. So if the beans are producing carbon dioxide, we will know it because the bromthymal blue will turn yellow. So that's really the basis of this experiment.